Hey, welcome back to Math with Patrick. Today is October 16th, and we're solving problem 289 from the Daily Epsilon calendar. And we should figure out why 16 is the number of factors of 18,900 that are square-free. So just vocab word real quick, square-free means a number that does not have any square factors. So like if we tried factoring 15, we have 5 times 3, and neither of these are square numbers. To give a non-example, I think we could do, like 75, because this is 25 times 3, and then 25 is a square number. And then like any prime number is going to be square free because like we have, okay, well, I guess technically 1 is a square number. That's like 1 squared. But that's not like the meaning or the essence behind square free. Basically, we need some number that's not 1 that is squared in the prime factorization. Or raised to any even power, honestly, because any even power we could just rewrite as a square. And so if we find any even powers in our prime factorization of a number, that also demonstrates that that number is not square free. So I think we should just start by finding that prime factorization of 18,900. And I'm just going to use a factor tree. Like clearly to me, it's 100 times 189. I think the 100 is a little bit easier to deal with. We could do maybe 25 times 4, and that, I guess we could have done like 10 times 10. But this is 5 times 5, and then 2 times 2, all of which are prime numbers. 189 looks a little bit harder, but I notice that the digits sum to a multiple of 9. So that does mean that this number itself is divisible by 9. And that's going to be, okay, well, 9 goes into 180 20 times. So this should be 21 times for 189. And then I can factor 21 as 3 times 7, and then 9 as 3 times 3. Okay, so in finding the prime factorization of our big number, I can now create factors of this number. Essentially, a factor is just a number that multiplies to get to another one. So I could grab like this 3 and this 5 and get 15. And I know that 15 times whatever the other ones are is going to get me to our target number. So to build factors of 18,900, all I need to do is pick some amount of 2's. And it looks like I have up to 2 that I'm able to choose. And so I'll kind of put like a 0, 1, or 2 beneath it, just to show that when I'm building a factor of 18,900, I could pick no 2's, 1, 2, or all of my 2's. And I'm conveniently forgetting that whole square free part for just a sec. The next largest number, the next largest prime is 3, and I have 3 of them. So when I create a factor of our big number, I can pick up to 3 of them. We have 2 5's, and then it looks like we have just the 1 7. Okay, and so to create a factor of our number, I could choose, essentially have 3 options for the number of 2's I have, 4 options for the number of 3's, 3 options for the number of 5's, and then 2 options for the number of 7's. Either I have it or I don't. And if we multiplied all these together, this would show us the total number of factors that 18,900 has. Just to see what that number is, looks like it's 9 times 8, which is 72. And so, fortunately, our answer is indeed less than 72, because how could we have more than that? So now we need to figure out how can we remove those square-free factors. Earlier, I mentioned that if we have an even number as an exponent in our prime factorization, like let's say I grab both 2's, one of the 3's, one of the 5's, and not the 7. And then if I have this even exponent right here, it makes me have a non-square free number, or like a square full number. I don't know. But because a square number is a factor of whatever this is, it is not square free. One thing I didn't realize, though, is that it's not like an even exponent that's the issue, but it's really any exponent that is 2 or more. Because let's imagine grabbing this 3 right here. So let's take 1, 2, all the 3's, 1, 5, and 1, 7. So whoops, that's going to be 2 times 3 cubed times 5 times 7. I don't have any even exponents, but I could just maybe like shove one of the 3's with the 2 for a sec and get a 6. And I have this 3 squared left over. This is the number 9. And then even though I started with an odd exponent, this number, whatever it is, once I multiply it all out, isn't square free anymore because there's a 9. So it's not the even exponent that's an issue for this problem, but it's just any exponent greater than 1. So basically, we only have 2 options for the number of 2's, 2 options for the number of 3's, 2 options for the number of 5's, and the number of 7's. And that gives us 2 times 2 times 2 times 2 options, which is 16. So we could feasibly grab none of them, and we would get the factor 1. And 1 is square free because it doesn't have any square factors in it like 4 or 9 or 16 and so forth. We could grab all of our numbers, 2 times 3 times 5 times 7. That's going to be, I think that's 210, right? Because this right here is going to be 6 times 5. Yeah, that's 30. Okay, cool. That's 210. And so 210 is going to be the largest of our square free factors of 18,900. And the instant that I tack on another 2 or 3 or 7, we're no longer going to have a square free factor. So that is how we can confirm the answer is 16. I don't need to list out all 16 of those factors to know that they indeed are 16 of them, and they indeed are square free. So I think that's about it. Thanks for watching, and I'll see you tomorrow. Bye.